Okay, so in this video we are going to have a look at the conjugate root theorem, and it's a formula that we use when we're dealing with what we call complex equations. So we'll have two parts to this video. The first part, for finding the roots, kind of introduces the idea of a complex equation, and then in the second part we'll actually apply the conjugate root theorem and see how it works. So if we look here at part 1, they have given us an equation, z squared minus 6z plus 13 equals 0. And if we think about a quadratic equation, its form is ax squared plus bx plus c equals 0. So this is actually a complex quadratic equation that we're dealing with. So that tells me that I can use the minus b formula to solve it. Factors of 13 are 1 and 13, so we can't use guide method. And instead of solving for x, we're just going to solve for z. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. My a value is 1, my b value is minus 6, and my c value is 13. And we just sub into the formula, and we know because it's a quadratic we should have two solutions, and because we're using minus b formula with the plus and minus, we'll end up with two solutions. So it's z is equal to minus 6 plus or minus 6 squared minus 4 times 1 by 13. So it's the exact same process as minus b. We're just solving for z instead of solving for x. All over 2 times 1. Tidy up. So that's 6 plus or minus 36. Now this part we'd usually just put straight into the calculator, but you'll see here we'll get a negative answer. So it's a better approach to kind of oversimplify when we're dealing with the root. So that's minus 52 all over 2. So if you put this as a whole into the calculator, it'll kick back an error. So you deal with under the root by itself. So 36 minus 52 will give me minus 16. Z is equal to 6 plus or minus root of minus 16 all over 2. Now we know that root of minus 1 is equal to I, so we're going to rewrite this as z is equal to 6 plus or minus root 16 multiplied by root minus 1 all over 2, and I know I can tidy that up then. Root 16, which is 4, root minus 1 is I over 2, a bit more simplifying to do. So we have 6 over 2 plus or minus root 16 we knew was 4 I over 2, and now we can apply our, we'll tidy up one more time. 6 divided by 2 is 3, 4 divided by 2 is 2, so it's 3 plus or minus 2i, so we get z equals 3 plus 2i, or z is equal to 3 minus 2i. There's my two roots, and that's my two answers. It was a quadratic equation, just in complex form, that's all. But we got our two equations, so that's us done. Part 1 answered. So now what we'll do is we'll have a look at part 2 here. So we were asked if it deals with forming an equation. So we're told f of z is equal to 3z cubed minus 5z squared plus 13z plus 5. So the conjugate root theorem tells us that if, so here we have 1 plus 2i, they tell us it's a root. So the conjugate root theorem tells us if a plus bi is a root of an equation, then a minus bi is also a root. And also because we have the conjugate pairs, if I'm dealing with a quadratic equation and they give me one root, then I am able to find my other root by finding the conjugate. If they give me a cubic like they've done here, if I am given one complex root, I can find my other complex root, but then we have to use the conjugate theorem to find the equation itself. Okay, so we have 1 plus 2i is a root, and then 1 minus 2i is my other root, and the conjugate theorem tells me to form an equation it's z squared plus sum of the roots, minus sum of the roots multiplied by z plus product of the roots equals 0. So for the sum of the roots, we're adding them. 1 plus 2i plus 1 minus 2i. So that's 1 plus 1 plus 2i minus 2i, which is equal to 2 plus 0i, which we can just leave as 2. And for product, we multiply. So it's 1 plus 2i multiplied by 1 minus 2i. 1 by 1 will give me 1. 1 by minus 2i is minus 2i. Plus 2i by 1 is plus 2i. And then we get minus 4i squared. We know that I squared equals minus 1. So a bit of tidying up. Minus 2i plus 2i is 0. Minus 4 times minus 1. So that's 1 plus 4 is equal to 5. And now I just fit it into the formula. So it's z squared minus sum of the roots, which was 2 times z, plus the product of the roots equals 0. And they had told us originally that f of z was equal to 3z cubed minus 5z squared plus 13z plus 5. So I have a quadratic here and we have a cubic, so we know we found 2 of the roots, we have one more root to find. If I divide this quadratic into the cubic, it will give me my final root. So I have z squared minus 2z plus 5 into 3z cubed minus 5z squared plus 13z plus 5. Z squared into 3z cubed is 3z, multiply out, we get 3z cubed minus 6z squared plus 15z. Draw the line, change your sign, cancel there. So minus 5z squared plus 6z squared will give me z squared minus 2z, and pull down the 5. And if we look here, z squared minus 2z, z squared into z squared will be plus 1. And then multiply out, and we get z squared minus 2z plus 5. Draw the line. And we knew this will happen. Change your sign and they'll cancel. And that tells me that my last root is 3z plus 1. We just need to write it as z is equal to, so we get 3z equals minus 1. So z equals minus a third. So that's my last root. So we have 1 plus 2i, 1 minus 2i, and minus a third. And that's us done using the conjugate root theorem.